Welcome to AQA Level 2 Further Mathematics, 5 random questions. This is video number 4 and these are all calculator paper questions. First one, this is a circle theorem question and we've just got to work out the angle Y, which is down here. Just a few things to note. This is an isosceles triangle because these are both radii of the same circle. Okay, so we can easily work that out if we know what x is. But to find x, we need to use the fact that the angle at the center is twice the angle on the circumference. So we can simply say that x plus 62 is the same as 2 lots of 2x minus 50. Okay, so that is equal to x plus 62. So we can solve that equation to find out what x is. So that gives us 4x minus 100 equals x plus 62. Rearrange that to give me 3x equals 162, and therefore x is a third of that, which is 54. Okay, and then we go to our angle, which we call angle BOC. So angle BOC is going to be x, which is 54, plus 62, which is 116. Okay, and then the angle Y is going to be a half of 180 take away 116. Okay, because it's an isosceles triangle, so the remaining angle has to be shared into 2, and that comes out to be half of 64, which is 32 degrees. Okay, it doesn't ask for any reasons, it just says work out the angle Y, and that's what we've just done. Okay. Next question. This is about differentiation. In fact, it's about finding the second derivative. That's the rate of change of the rate of change. So what we have to do is, first of all, split this into 2 fractions. Okay, so we can say that y can be rewritten as 6x to the 9, okay, over 2x to the 4. Plus x to the 8 over 2x to the 4. Okay, I would show all the steps with this because it's worth 5 marks, I think. And so the next step would be to simplify both of those, and that would give me, well, it would be the 6 over 2 will give me 3, and it would be 3x to the 5. And then it would be plus a half of x to the 4. Okay, now you can differentiate it. So dy by dx, bring the power to the front, drop it by 1. We would have 15x to the power 4. Put the 4 in front, that would give us 4 over 2, which is 2x cubed, and then we want the second derivative, d2y by dx squared, so we just differentiate again. Okay, and that will give us 60x cubed, and it will also give us 6x squared. And then we've got to find the value of that when x is a half. Okay, so I'm just going to use a half rather than 0.5. So when x equals a half, d2y by dx squared, d2y by dx squared, okay, is going to be 60 times x cubed, well, that's an eighth, okay, and it's also going to be 6 times x squared, which is a quarter. Okay, and you can put that on a calculator if you like, but it comes out to be exactly 9, and that's the answer. Okay, next question. This is a sequence A, the nth term is given by that rule. For B, the nth term is given by that rule. The kth term of a sequence A equals the kth term of a sequence B. So basically all we need to do is find this number, this value of n, which they're calling k, and set them equal to each other. So k over 14k plus 30. Okay, and that must equal 2 over k. Now it emphasizes in the question that you must show you're working. So you have to put down all the steps, okay? Otherwise you're not going to get the marks. So you have to put down all the steps. Cross multiply, so we would have k squared, okay, equals 2 lots of 14k plus 30. So I'm just cross multiplying over the equal sign. Then I'm going to expand out the brackets. K squared equals 28k plus 60. And then I'm going to subtract all that from the left to give me 0 on the right. So k squared minus 28k minus 60 equals 0. Okay, and then I need to put try to factorize it, which I can do. Okay, and it's going to look something like this. The factors of 60 I'm interested in are going to be 30 and -2, or rather -30 and plus 2. Okay, now I can conclude from that k equals -2 or k equals 30. All right, it can't be this because it has to be a positive number, because the nth term of a sequence is a positive number. So it can only be that one. So k greater than 0, therefore k equals 30. That's how I would show how I'm eliminating that one there. Okay. Next question. Nothing particularly difficult here. You've just got to be careful that you account for all the lengths. So this is a rectangle with a corner cut off, and the perimeter of the shape is 252, and I've got to show that that equation is true. Now what I'm going to do is just add some extra information here, and that is that this height here is 15x plus y. Okay, because it's the same as that piece there plus that piece. Okay, so the total perimeter, okay, I could do it like this. If I call the perimeter P, okay, well, I don't need to use P, I can just go straight to using 252. So in fact, if I just show that I've got 30, okay, plus 15 plus 10 plus 20 plus 15, and all those are multiples of x, so I just need to times the sum of all that by x. Okay, so what I've done, I've just taken these 5 values here containing x, okay, and added those together, Okay, and now I've got left over a y and another y, so I've got 2y left over. So I'm just making sure I've accounted for all of the lengths, and I know that that equals 252. Okay, well, if I combine all of this bracket together, that comes to 90x plus 2y equals 252. Okay, 90x plus 2y equals 252. Okay, doesn't look much like this, but that's simply because there's a common factor of 2, so we can go straight to saying 45x plus 1y equals 126, and therefore y equals 126 minus 45x. Okay, so it's just a bit of algebraic manipulation, but obviously you need to make sure you've accounted for all the lengths in your working. Okay, this one here, show that the area is that. So again, it's a show that question. You've got to have all the steps in place to get that answer. Okay, so we're going to have to put some careful algebra down here. Now, I've decided that the simplest way of doing this is to use these two rectangles here. Well, it may not be, it's one way of doing it anyway. So I'm just going to divide it up into two rectangles. Okay, now this one here is easy because this is just 15x times 10x, which is 150x squared. So that's the area of that smaller rectangle there. I'm just going to write it in there. And then I've got to do the other one, which is made of 20x times 15x plus y. Okay, so I've got 20x times 15x plus y plus 150x squared, okay, which is equal to the area A. Now this comes to, if I multiply that out, I'm going to replace the y term with whatever it is in terms of x, which is this thing here. So I'm going to write it as 20x times 15x plus, instead of writing y, I'm going to write 126 minus 45x plus 150x squared. Okay, on the next line I'm going to start expanding this out, but in fact before I do that I'm going to collect those two terms together. So I've got 20x and then I've got 15 minus 45, so that's going to be 126 minus 30x plus 150x squared equals A. Now 20x times 126 is 2520x minus 600x, that's 20x times 30x, 600x squared plus 150x squared. Okay, and one more step, which is to simply combine those two terms there to give me that A equals 2520x minus 450x squared. So in these show that questions, you've got to put the working down. That's how you get the marks. Okay, you can't just take shortcuts. So it will require a lot of writing, but just step by step. Now for part C, use differentiation to work out the maximum value of A. So what we need to find is this quantity here, dA by dx. In other words, we need to differentiate it. So the maximum occurs when the rate of change is 0, you see. So you need to find out what dA by dx is, which is equal to, well, we just simply remove the x. That will give us 2520. Okay, and then this one, the power comes to the front, so it becomes 900x. Okay, and that has to equal 0 at a maximum, okay, or a minimum. So we can assume from the question that it'll be a maximum. Therefore, from that 2520 must equal 900x. Therefore, x equals 2520 over 900, and that simplifies quite nicely to 14 over 5. Okay, and it just says work out the maximum value of A as x varies, so 14.5 or 2.8 centimeters. Okay, and that's the answer. Next question. This is about functions. F of x equals this function, g of x equals this one. There's a bit of boundary information. X has to be greater than or equal to 5, because if it wasn't, this wouldn't be a real number. All right. Work out the value of g of f of 4. So that means that we need to apply the function g, right? So we need to apply the function g to f of 4. And f of 4 is 3 times 4 squared plus 6. Okay, which is therefore equal to the function g of that, which is 54. Okay, and the function g of 54 is equal to the square root of 54 minus 5. Okay, and as you can probably see, that's very conveniently the square root of 49, which we know to be 7. And by the way, when you take the square root, although negative 7 squared is also 49, the square root is always taken to mean the positive square root only, unless you're asked for the other one as well. All right, so that's how you do it. And that's the most efficient way. So you didn't actually need to find g f of x as a function. You could have done it that way, but that would take a bit longer. However, in this one, we need to find f g of x. So we need to apply the functions in the opposite order, but with x as the subject rather than a number. All right, so f g of x is equal to f of the square root of x plus 5, sorry, x minus 5. Okay, and that is equal to 3 lots of the root of x minus 5 squared. Now I'm deliberately writing it out in full to show that. Okay, I know that the square root of x minus 5 squared is just x minus 5, but I'm still showing the steps because I want the marks. Okay, plus 6. And then I can do the step I just said. Well, that is the same as 3 lots of x minus 5 without the square root or the squared plus 6. Okay, and that is equal to 3x minus 15 plus 6. Okay, 3x minus 15 plus 6. And that is equal to 3x minus 9. Okay, and that is equal to 3 lots of x minus 3. And that's in the form that the question required, because it said, show that it can be written in the form of 3x minus 3 in this case, or x minus a in general. Okay, so that confirms really that we've got the answer correct, because well, it indicates the answer is probably correct, which it is, of course. Okay, that is the end of the 5 questions, and there'll be another one coming soon. Thank you for watching.